Hello, this video is going to be for chapter 4 lesson 1, which is about identifying linear functions. Now linear functions are nothing new to you if you've been watching the videos, because already we have done enough in detail about linear functions. But again, as the lesson suggests, we are going to identify linear functions, which is the basic of the remaining chapter. And all of course is going to be about linear functions, right? Now previously we did see how can we identify linear functions. That is, and also we learned how to identify functions. If you do remember, we did learn how to find out whether the given function, how to identify a function, and how will it not be a function. Now in this particular lesson we are only going to see whether it is a linear function or not. Now first of all, before learning how to identify linear functions, let's just quickly go through what is linear. Linear means straight, right? So function means equations or any table which is given related to any sequence of numbers, right? So function, now linear function put together means if you would graph, that would give you a straight line. So a linear function, if graphed, would give you a straight line. That's what is linear function. Now there are many ways you could find linear functions. The first one is by graphing. If you graph the given information, that's the given table, or we will use our own coordinates and we will find the values and graph. If you would graph, if that is a straight line, then it is a linear function. And if they have given you a table and they ask you to find whether it's a linear function or not, if the values of y is constant, then it is a linear function. Value of y should be constant. Constant means the same. The difference between the values of y should be equal, not one after the other, or not many differences. It should all be the same difference. For example, if you're adding 3, it should be plus 3 for all. If you're subtracting 5, it should be subtract 5 for all. It cannot be somewhere plus 3, somewhere minus 2. It cannot be like that, right? Now another way, rather we could say this is the standard form of linear function. So what is the standard form of linear function? It is ax plus b sub y equals c. So this is the standard form of linear function. If you can write any equation in this particular form, then it is known to be a linear equation. So you have to remember this because this is the standard form of linear equations. Right, now let's get started with this question. Here they have asked us, identify whether each graph represents a function. Explain if the graph does not represent a function. If the graph does represent a function, is the function linear? And now how do we know whether it's a function or not? Again, as I am saying, in the previous lessons we did learn a function means the value of x should not be repeated. The value of y gets repeated doesn't matter, but the value of x should not be repeated. This is the rule to identify whether it is a function or not. Now let's see. And I already started by saying a linear function means it should be a straight one. First of all, is the given graph a straight line? No. So which means it is not a linear function. But is it a function? Let's check. It's not linear because it's not straight. But let's check if it's a function or not. Now what's the rule for function? It should be straight. The value of x should not be repeated. So let's check whether the value of x is repeated anywhere. Here it's 1. So 1 is with 0. It's not repeated. So a pair of coordinates can be written as 1, 0. How about 2? 2 again a negative 3. And how about 4? It's again negative 2.25. Then for 5, it's a 0. So the value of x is not repeated anywhere. If you would notice, if you go through slowly, one by one, the value of x has not got repeated anywhere. So this is a function, but not a linear function. So we are going to say it's a function, but not linear. All right, so what are we going to say? They said explain if it's a function. So why are we saying that it's a function? We are going to say because each domain value, I hope you do remember the meanings of these words. Each domain means the value of x. So each domain value is paired with only one range value. It's paired with one range value. Now this is how I write. You can write it in your own words, saying the value of x is not repeated. So it really depends, but the idea needs to be the same. Each domain value is paired with only one range value. In fact, they should be only here, or exactly one range value, which I forgot to write. So it should be exactly or only one range value, right? Let's go to the next question. Now this is a circle. All right, now let's see whether it's a function. Is it linear? Of course it's not linear, right? So it's not linear, but whether it's a function, let's see. Now choose any coordinate, okay? So for example, -2. So I'm taking -2. If I would take -2 is going here, right? As well as -2 has another value which is here, which is a 6.5, -6.5, and -2 also has a value of -2, -2 with 2.5, we could say. So there are two values for -2. Let's check for one more. Now they're not needed, because once you find out for one x value, the values have been repeated, it automatically becomes not function. Let's check for -6 here. Okay, these are the values of x, right? We have 0, we have -2, all these numbers. So let's check for -8. Now -8, if you would go up, that's touching the circle here, that's about -1.5, the value of y. And also if the circle, you can touch down as well. So again, -8 has two pairs of y values. So which means it is not a function, right? Because the values of x have been repeated. So not a function, and not a linear function at all, because it's not a straight one. And also, so you can write not a function or not a linear function, as you could see. And we have to explain why, because you can say the domain values have been repeated. Okay, domain values have been repeated, or you can say domain values have been paired with many range values, we could say, right? Or two, like we found out two with two range values. So it totally depends on how you want to write it, but the idea needs to be the same. Okay, so this is how from a graph you find out whether it's a function and whether it is linear or not. Right, let's move on to the next question. What does the question say? Which set of ordered pairs satisfies a linear function? Now they have given you pairs of coordinates, right? Now to make it more simpler for you, let me write it down in this way. We are going to write the value of x here and y here. Okay, so that this is just to make you understand only. If you can do it directly, you can go ahead and do it. So as I said, the value of y should be same, or it should be constant. So when the value of x is 5, value of y is 1. Then it's 4, here it's 4. Then 3, 9, 2, 16, 1, and 25. All right. Now what I just started the lesson by explaining from a table, how do you find whether it is a function, linear function or not. Check this. This is a -1, because 5 minus 1 would give you a 4. Similarly, 4 minus 1 would give us a 3. 3 minus 1 would give us a 2. And again, 2 minus 1 would give us also a 1. Right? Now, all the x values are constant. All of them are same. Let's move to the value of y. 1, of course, plus 3 would give us a 4. Then 4 plus 5 would give us a 9. 9 plus 7 would give us a 16. 16 plus what would give you a 25? 16 plus 9 would give you a 25. So which means literally we are finding the differences among them. Now, see the values of y? They are not constant. They are not the same. It's plus 3, plus 5, plus 7, plus 9, which means this ordered set of pair is not a linear function, right? So we have to say here, not a linear function. And they said explain, so you can explain it in your own words, saying the value of the changes in value of y is not constant. That's how you explain. Now similar way, let's do for set B. This was for set A. Let's do for set B. Writing this like this would make it easy for you to solve, like find out the difference. It's not necessary, but better you write. Right, so x is 1, y is negative 5, x is 2, y is negative 3, x is 3, y is negative 1, x is 4, y is 1, and 5 and 3. Alright, let's find out the differences among them. So the differences of x is going to be 1. How did it become 2? Plus 1. How did the 2 become 3? Plus 1. How did the 3 become 4? Plus 1. And how did the 4 become 5? Plus 1. Now let's go move to the value of y. What's the difference between a negative 5 and a negative 3? Negative 5, negative 3 means some numbers are being added because the values of the negatives are increasing here, right? So negative 5 plus 2 would give you a negative 3. Now, negative 3, how did it become negative 1? Because of plus 2. Now, if I would draw a number line, I'm just drawing, maybe some might be wondering what's happening here. So I'm just drawing to explain only. So this is negative 5, negative 4, negative 3, negative 2, negative 1, and 0. Right. So let me write down 1 here as well. Okay, so from negative 5, you're moving to negative 3, which means you're adding, because you know when you go to the right means you're adding. So adding how much? Plus 2. So this is plus 2. The same way from negative 3, you're going to negative 1. So which means again, it's a plus 2. So it's plus 2 again. From negative 1, you're moving to 1. So negative 1 moving to 1 means from here to here, it's a plus 2 again. In fact, I should not be drawing number lines at this point of time because you all know how to get the answers, but still to make it clear for you, I'm drawing. Now look at the changes in y and x. It is constant. So what does that mean? If the changes in x and y are constant, that means it is a linear function, right? So we say it's a linear function. And explain means, well, how are you going to explain that? You're just going to say there is a constant change, or the changes in the value of y is constant, or there's a constant change in the values of x and y. That's how you explain it. As simple as that. So which set of ordered pairs satisfies a linear function? The question is set B satisfies a pair of linear functions. Easy, right? Let's move on to the next question. Write y minus 2x in standard form and then graph the function. Now, I did start the lesson by explaining you about the standard form. What was the standard form of linear equations? A sub x plus by equals c. This is the standard form of linear equations. Now they are asking us to write this equation in standard form. So here you can say it's y equals negative 2x. So to make it into standard form, what I'm going to do is I'm just going to move this negative 2x to this side. So what happens there? It becomes 2x plus y, and because we move the 2x to the other side, here there is nothing. So that means 2x plus y equals 0 is the standard form. Check it. Is that in the standard form, which is ax plus by equals c? Yes, it is. See, you can see the values. Here you know there is a 1. When there is no number means the coefficient here is going to be 1. So 1y equals c. That's how you change any equation into standard form. Now we are going to graph it. Right, now to graph this, we are going to draw a table. All right, so we will have the values of x and y. That would make it easier for us. Not needed much of numbers, just choose 2 or 3 values. That would be more than enough for you because it's a very small graph. So we make this a bit longer so that I can take 3 values. Okay, so here we are going to write the value of x, and here we're going to write the value of y. Now, what are the values of x we are going to give? It's totally up to us what values of x we are going to give. All right, you can take 0, you can take 1, 2, 3, any numbers you want to, but do make sure that you take the numbers which are in the graph. Like say if you say x is equal to 9, where is 9 in the graph? We don't have. So you have to be a bit sensible when we are choosing the values of the domain. So let me take these as 0, and 2 and a 4. It's perfectly all right even if you would take 1, 2, 3, or even negative numbers if you take, it's fine. It's totally perfect. Okay, now here let me now what you're going to do is substitute the value of x here. So starting with 0, 2 multiplied by 0 plus y equals 0, 0 plus y equals 0, which eventually gives you y equals 0, which means when x is 0, y is 0. Now let's check for 2. 2 multiplied by 2 plus y equals 0, which means 4 plus y equals 0. Y equals 0 minus 4, so y equals a negative 4. So when the value of 2, the value of x is 2, the value of y is a negative 4. Okay, now let me take 4. I think I need to change, because if it's negative 4 for 2, then okay, for 4 it's going to be a bigger number. Now, to those who don't understand what I'm saying, see, for example, this. Now, if I would solve this, I'm going to get 8 plus y equals 0, which means y equals negative 8, but I don't have negative 8 in the values of y. So let me reduce these numbers. Let's take a negative number instead of 4. Okay, so let me just rewrite that. Here it was 0, here it was 2, so 0, negative 4. Let me take as a negative 2. Okay, so when x is 2 and x is a negative 2, which means 2 multiplied by negative 2 plus y equals 0. Negative 4 plus y equals 0. Y is going to be equal to 0 plus 4, which is y is equal to 4. So when x is negative 2, y is 4. Now definitely the answers here will vary, because it totally depends on what points you have taken. So definitely it's going to be different for you and for me, but then the line is going to be the same. Okay, so negative 2 and 4, that's here. 0, 0 is here, this point, and then 2 and negative 4 is here. So that you've got 3 points now, just join them. That's all you need to do. So to join them, okay, do use the ruler. Don't draw it with free hand, because graphs never come perfect with free hands. So this is how your graph needs to be. Now from this graph, I could say, like, if you would have taken 1, the answer is going to be a negative 2. If you would have taken 3, you will get a number bigger than, more than the value of x here, y here. So you can even change the coordinates and draw the graph accordingly. Moving to the next question, this is the last question we have for this chapter. What does the question say? In 2005, the Shabelle River in Somalia rose an estimated 5.25 inches every hour for 15 hours. The what increase in water level is represented by the function f of x, which is also y, equals 5.25x, where x is the number of hours. Graph this function and give its domain and range. Okay, so here we have to draw the table and we have to graph it, and then also we are going to give the domain and the range. First, let's draw the table. So to draw the table, what is the value of, okay, we have 15. So that means let's take some regular number, like not all the numbers, somewhere in between we'll take the numbers. But we have to use all the numbers because they said give the domain. So which means we are going to use all the numbers which are there. This is going to be our table. We will extend it whenever, however it's needed. Okay, so here we are going to write the value of x, and here we will write the value of y. So always it's better we start with 0, right? But then 5.25 multiplied by 0 is going to give you a 0. So 0, 0, you can do that with your mind. Let's start with 2. Okay, just take regular number, like interval numbers. Don't take 2, 3, 4, because you have to reach until 15. So let's take 4 values, but then do make sure that you choose proper numbers. So let's take it as a 2 and a 4 and then 8, and then let's take as 12, and then finally 15. Okay, so just separate these columns. Now we are going to work it out with the formula. So the formula given for us is y is equal to, or f of x is equal to 5.25x. Okay. So which means this is the formula, y equals 5.25x, which means you're going to substitute the values of x here. So to get started, first we'll start with 5.25 multiplied by 2. This is going to give you 10.5. Alright, so write 10.5. And then 4. Now it's not necessary you choose the same numbers as me. No, it's not necessary. You can choose any numbers in domain. But then your answers will differ. Here in the table, the answers will differ, but the line is going to be the same. So 5.25 multiplied by 4, that would give you 11, right? This is 11. And then y is equal to 5.25 multiplied by 8. So this is going to give you 1642. Okay, I think it's right. 8 5s are 40, 16, 17, 18, 19, 20. Yes, it's 42. So when ax is 8, y is 42. And the same you will do with 12 and 15 as well. So the next equation is going to be y is equal to 5.25 multiplied by 12. So 5.25 multiplied by 12 would give you 63. Then y equals 5.25 multiplied by 15. This would give you 78.75. So here it's 63 and here it is 78.75. Now 75.75 means it's a 3/4. You need to know a 3/4 is the decimal for 0.75 is the decimal for 3/4. So when you're graphing, you need to have an idea about that. So let's start graphing now. That's all we have to do. Okay, so to start graphing, let's start with 0, 0, because we know 5.25 multiplied by 0 is a 0. So our point starts here. Then for 2 it is 10.5. So 2 is here. Now here it is 10 and then a space 20. So what's in between 10 and 20? It's 15. But we need a 10.5, which means it's going to be very slightly above 10. Somewhere here. I cannot draw the circle big because that would denote a 12. So just a bit slightly 10.5. And then for 4 it's 11. So again a bit above the line, you could say, not even so. In fact, this cannot even take the place of the there. It's going to be like that, almost on the line. I think this is 12, not 11, right? 5. What's happening to me? It's 5.25 multiplied by 4 is 21. Why did I write 11? It's 21. So which means 21 is here. 20, a bit, very slightly above 20, almost at 20, little bit above 21. And then for 8, it's 42, so this is 40, a bit above 42, a bit above is 42. Then for 12, it's 63, so 60 is here. So 63 is going to be very near to 65 because 65 is in between. And for 15, it is going to be 78.75, which is almost near 80. So these are the points we have, and then we are going to join them. So to join them, start from here till here. Now, yes, you might feel that some of the points are not online. That's because, see, for example, this one. Okay, now this is my mistake here because it is 7 I graphed. It should be graphed at 8. because it's 842. So that's here. So this is how you graph. Now see, even if you do any mistake and you start graphing, you will know if a point is above or below. You can check it accordingly and then draw the graph perfectly. So this is how your line is going to be. Now the last part of this question is graph the function and give its domain and range. So how are I going to write the domain for this question? You know, domain means the values of x. So it starts from 0. So you say 0 is less than or equal to x, less than or equal to the maximum value given here is 15. This is domain. And how about the range values? The range is given to be starting from 0, right? Less than or equal to y, which is less than or equal to, which is the maximum number we got in the graph here. It was 78.75. 78.75. This is going to be the range. So that's all is the lesson. Hope you have understood. Do comment and let me know whether you got the answers right or not, or maybe if there is something easier which you could find out, right? And do like the video. So till we meet again, keep practicing.